Kia ora Year 12 and Year 11. This is a question from 2004 and it's an optimisation question. So we're asked to find a minimum here. Right, let's read the question. A 10 centimetre cubed block of metal is to be melted and made into a cylinder that has the smallest possible surface area. And we're given the formula for surface area down here. Assuming that the volume of metal does not change in the process, find the radius of the cylinder. So my goal is to minimise surface area, which is 2 pi r squared plus 2 pi rh. Okay, and we're doing that subject to v, which is pi r squared h equals 10. So when we try to minimise this expression here, we're going to hit trouble if we try differentiating straight away. And that's because this currently has two variables in there. It has the r's and it also has h. So our usual strategy with minimisation or maximisation problems is that we want to get rid of one of those variables. And the way we do that is by using what I call our constraint. Okay, so we know that the volume of the metal must be 10 cubic centimetres. So that lets me rewrite this expression so that I get h equals blah blah blah. Then I take that h and I substitute it back into here. That means that I now have an expression for surface area that's a function of one variable, and that makes it really easy to go ahead and differentiate. Okay, so usually the first step in these problems is to identify the constraint and rewrite it so that we can substitute something back. So here we go. So we have h is equal to 10 over pi r squared. Substituting back in, we get SA, I'll go back to blue, it's a bit nicer. SA is equal to 2 pi r squared plus 2 pi r times 10 over pi r squared. Alright, so the next step obviously is going to be to simplify that expression and clean it up a little bit. I'll do that on the next slide. Okay, so we get SA is equal to 2 pi r squared plus 20. Now the pi's simplify out, and we had an r in the numerator and an r squared in the bottom. So now we've got just r here. Okay, so look at that. I can go ahead and differentiate. But first we'll rewrite it like this. So our mission is to minimise the surface area, and this is it here. So for a minimum, we need dSA by dr is equal to 0. So let's figure out what that is. So dSA by dr is equal to 4 pi r minus 20r to the negative 2. We're going to set that equal to 0. Now rearranging that, I get 4 pi r is equal to 20 over r squared. So let's collect all of the r's up together. I'm doing this in lots and lots of steps. It's fine if you want to miss some of them out, okay, as long as you're working as logical. So we get 4 pi r cubed equals 20. R cubed is equal to 20 divided by 4 pi. So if we take our calculator, let's see what we get for that. So that's going to be 5 divided by pi, and that gives us r cubed is equal to 1.5915 da da da. So just hold that number in your calculator, don't write it down, and definitely don't round it to 1.59. And now we're going to take the cube root of that. So the cube root gives us r is equal to 1.1675. And that's to 4 decimal places, but it's not very good because I haven't said my units. So better is to write that the radius will be 1.17 centimetres for that one there. Okay, make sure that you can go through each step of that on your own. That's a pretty classic kind of level 2 optimisation problem. They all follow a similar pattern. Thanks for watching, and please do let me know if the video worked okay today.